energy. We know that the biggest source of energy for us is the sun. It is a natural source of energy. From the sun, we derive many energy sources. In our daily life, we keep talking about energy to do work. So we know there is a relation between work and energy. So to do work, we say we need energy. Like nuclei of atom, we get energy sources. We get energy from under earth. We get energy from tides. So there are many other sources which give rise to the energy for our livelihood. The water, we get hydroelectric energy. We get thermal energy. So there are many energies, energy sources from which we derive energy to deal with our lives. Let's understand what this energy is. Let's take an example where a cricket ball goes fast and hits the stumps, the wicket. Then what happens? The bails will fall off. When it goes and hits fast moving ball, when it hits the wickets, what happens? Bails will fall off, or sometimes the stumps also will fall off. Take an example of a balloon filled with air. Squeeze it gently. What will happen? That means you are using some force to press it. You press the balloon. Now release that force. It will come back to its shape. But you press the balloon with more force. Then what will happen? There will be air pressure that increases inside, so it can burst. Let's say there is an axe and a wood, and wood piece is there, and this wood piece need to be cut, and we cut the wood piece using an axe. When axe is used to cut this wood piece, what is the first thing that's being done on this? Let's say this example of wood and axe, and understand the energy. First, what a person does, he raises the axe. So in raising the axe, what happens? Some work is done. We lift the axe vertically above the log of wood. Then there is a work done. Some part of that work is done in raising the axe itself. Correct? Part of work done in raising the axe. The other part of the work, what happens? This is getting stored in the axe. Now what happens? We hit the wood with the axe. Now when the axe falls on the wood, let's say axe fall on the wood. When axe falls on the wood, what will happen? It cuts the wood. So the wood becomes into pieces. Now what actually happened in this case? The stored work in the axe gives the axe ability to do the work of cutting. So the stored work in the axe, when you raise the axe, some of the work got stored in the axe. That stored work gives the axe ability to cut the wood. this ability to do work is energy. See, further going on this example, now the axe is on the wood, on the cut pieces of the wood. Will it do any work now? Nothing. For it to do work again, we need to raise the axe once more. Then again the work gets stored in the axe, and that work will be consumed by the wood. So what happens basically? The energy is nothing but axe's ability to cut the wood. So axe has released its energy while cutting the wood, and the wood gained that energy from the axe. So we say object which does work, that is in this case axe, loses energy because it has done the work. Object which does work loses energy. In this case, the axe which has done the work of cutting the wood lost energy. And the object on which the work is done gains energy. So we say an object that is capable of doing work possesses energy, and after doing the work, it loses energy, and the object on which the work is done gains energy. Having understood what is energy, let us see what are the units for energy. Energy is nothing but, in a way, it is ability to do work. So the work units will hold good for energy. Units are, for energy, is also joule, just like work. This is the SI unit. Since the work done is the equal amount of energy that is consumed, we can define now what is joule energy. In other words, equal amount of energy that is consumed. There is a work done by axe here. Equal amount of energy is consumed by the wood. If you see this example. So we define 1 joule energy as the energy required to do 1 joule of work is called 1 joule energy. And since this is a very small quantity, we generally represent energy for a bigger energy is kilojoule. So 1 kilojoule is 1000 joules. So K here represents kilo. And this joule, this name has come from the British physicist by name James Prescott Joule. So in his honor, the joules for the energy SI unit is named. Let us see next, what are the forms of energy? Let us say the definition of energy is ability to do work, and we also can understand by this statement, and the amount of energy possessed by a body is equal to the amount of work it can do when its energy is released. And this we have seen in a vivid manner in the example of wood and axe, which we described earlier. So, based on this explanation of energy, there are many forms of energy. So, let us list down the forms of energy, and then we will deal with 2 types of energies in detail. There are different forms of energy based on what are the sources we use for creating this energy. Kinetic energy, potential energy, chemical energy, heat energy, light energy, sound energy, electrical energy, and nuclear energy. Whereas we discuss in this chapter kinetic and potential energy in detail, and both put together are called mechanical energy because they deal with laws of mechanics.